Okay, we're now going to work on our activity for section 2. So in this activity, they're having us find the area of some figures, and they're having us work with a function. So we're going to understand from this activity what a function is. Okay, so just a little bit of vocabulary. So our inputs are going to be our x's. That's what we're going to substitute in place of x. And our output would be kind of like our y's, or in this case, it's our area. What we find out the area is. So another vocab terminology that can be used for input and output, this would be our domain. So x's are also known as the domain, what we start with. And then our y's would be our range, kind of what we go out to when we're working with our x's and y's. We'd always go to our home, our domain, our x first, and then we'd go out to our y, like we'd range out to the y. So input and domain are for our x's, and output and range are for our y's. Just a little bit of vocab terminology that we'll be using throughout this chapter. Okay, so what we are going to be doing is we're going to be finding the area of this triangle. So just a reminder, when we find the area of a triangle, we do the base times the height, and then we divide that by 2. So we're going to be substituting in for, it looks like our height here is what our x is. That's what we keep changing. Okay, so our base is 4, because if we add those together, that gives us 4. So that part's going to stay the same. Our height is what's going to continuously change. So we're going to go ahead and substitute in a 1 where x is. So 4 times 1 would give us 4 divided by 2. So 4 divided by 2 would give us an output of 2, or an area of 2. So now we'll go ahead and do the same thing. So this time we're going to put a 2 where our x is. So that's now going to become a 2. So 4 times 2 is 8. Divided by 2 would put us back at 4 for our area, or our output. Okay. Then we're going to go ahead and substitute in, again, a 3. So we have 4 times 3, which is 12, divided by 2, which would give us 6. And then we'll put our 4 in there. Now that's a 4. So we're going to do 4 times 4 divided by 2. So 4 times 4 is 16. Divided by 2 would give us 8 for our output, or our range. Okay, so now they also want us to write an equation that describes the function. So when we're looking at like each of our formulas that we have written out over here, well, what do we see is the same in all of them? It looks like we have this 4 times a number, and we also have divided by 2. That is the same in all of them. So what would 4 divided by 2 give us? That would give us 2, right? Okay, so that's what's in common. That's the same in every single one. So let's check to see if we did that 2 piece. So what's happening to 1 here to get us to that 2? Well, times 2 would get us there, right? So does that happen for every single one? 2 times 2, does that give us 4? Yep. 3 times 2, does that give us 6? Yep. So this is kind of what our function is. So what are we doing to every x? We're multiplying by 2. So to get our area, we are taking our x value times 2, or we're going to write it out like this. Area equals 2 times x. Granted, we had to do more steps to get there. We had to go times 4 and divide by 2. But in this case, when we simplify our equation and we kind of simplify out what was in common, we found out that really we could have taken just our x times 2. Okay, you guys probably aren't going to know that, but in the end, this is what our function ends up being. Okay, so let's go ahead and look at letter B. So letter B is working with a trapezoid. So normally at your guys' level, we might split this into 2 pieces. We might split it into 2 triangles, or we might go through and split it into a rectangle and a triangle. Just for ease, to make this a little bit easier, I'm going to teach you another method. And that other method is when you add together your 2 bases. So when we put those 2 together, how many x's do I get? Well, I get 3 x's total. We're then going to take that times our height. Okay, we're going to take it times 2. If it was a rectangle, we would do base times height, right? Well, here we have 2 bases, which is kind of weird. So we can't use exactly the same formula as a rectangle. So we're going to have to actually go ahead and divide by 2 in the end. quadrant because it's not a full rectangle. Okay, so now what we're gonna do is we're gonna go through and actually use this equation and we're gonna substitute in. So first of all, our height never changes. So this piece right here will never change. That is still going to be 2. So the only spot we're substituting in is for our x. So for our first one, we're gonna substitute in a 1. So we have 3 times 1 times the height is 2 divided by 2. Okay, so 3 times 1 is 3, times 2 would give us 6. 6 divided by 2 would put us back at 3. Okay, so now we're going to put a 2 into the x spot. So 3 times 2, and then we still do the times the height divided by 2. So times 2 is the height divided by 2 because it's a trapezoid. So 6 times 2 would give us 12. Divided by 2 would put us back at 6. So now we'll substitute in a 3. So 3, and then we put a 3 where x is, times 2 divided by 2. Okay, and some of you might start noticing, why would we go times 2 and then divide by 2? Well, I'm just fully filling in. So some of you might pick up on the fact that we could really just eliminate that step to get our answer. And we'll discuss that out in a minute. But 3 times 3 is 9, times 2 is 18. Then we divide by 2 again is going to put us at 9. Do you see how I would have gotten 9 right away if I just canceled out these last 2 steps? Okay, so finally 3 times, we're going to put a 4 in place of x, times 2 divide by 2. Okay, so 3 times 4 is 12, times 2 would give us 24, divided by 2 would put us back at 12. Okay, so now final step, we have to write our little function, like what is happening. So when I look through my equation, what do I have in every single equation? What is staying the same every time? I have this times 3 piece. I also have this times 2 piece and this divide by 2 piece. So really we're going to kind of simplify that out. So if I did 3 times the 2 and then divided by 2, well, that's kind of what I have circled here. What would I end up with? Well, 3 times 2 is 6, divided by 2 would put me at 3. So we're doing something with 3 every single time when I reduce down all of that together. So let's work with 3. So how can I get from 1 and turn it into a 3? Are we going times 3? How about 2 times 3? Does that give us 6? Yep. 3 times 3, does that give us 9? Yes. 4 times 3, does that give us 12? Yes, it does. So to get our output, which is our area, we are taking 3 times the x that we put in there. So there is our function. Okay, and you guys will work a lot more with this as we continue in. Right now, I'm just kind of introducing it to you. I know it looks complicated. It'll get easier the more you work with it.